Welcome to the Explainer. If you're still treating your interactions with AI like a glorified search engine, just typing in a question and crossing your fingers, we really need to talk. Today, we are moving way beyond the misconception that prompting is just basic text entry. Instead, we're going to learn how to build complex cognitive architectures for what is essentially an incredibly smart but highly literal AI intern. We are climbing the cognitive evolutionary ladder of AI prompting. Okay, let's look at our roadmap. We're taking our AI from basic instruction following all the way up to self-evolving reasoning. First up is the art of prompting, then thinking step by step, trees and graphs of thought, connecting to the real world, humanizing AI prompts, and finally evolving AI reasoning. Let's get right into it. Part 1. The art of prompting. This is where we explore how we can strategically direct a large language model's behavior to get completely novel insights without actually having to retrain its underlying code. Think of it like this. Giving the AI a blank canvas with zero direction, that's zero-shot prompting. You're basically just hoping it magically grasps your intention. But contrast that with few-shot prompting. That's where you condition the model by providing a small number of really high-quality examples right in the prompt. By seeing these demonstrations, the model instantly clicks with your exact criteria, which dramatically improves its accuracy. It's literally the difference between telling someone to do a job and showing them exactly how it's done first. Which builds right into part 2, thinking step by step. This is where we explore linear reasoning, which is basically the exact moment AI learned how to think out loud. Now, you might be wondering, why on earth does a supercomputer, trained on the entirety of the internet, sometimes totally fail at basic apples and oranges arithmetic? It seems crazy, right? Well, it happens because we force the AI to jump straight to the answer without processing the logic. You wouldn't tell a math student to just guess the final number without chewing their work. We shouldn't ask our AI to do that either. And the fix is actually beautifully simple. When a standard zero-shot prompt demands an immediate answer, the model often just panics and guesses wrong. But by using a technique called chain-of-thought prompting, we force the model to take steps, generating a sequence of short reasoning chains. Basically breaking down the intermediate steps completely unlocks the model's ability to solve really complex, multi-step math problems. It gets a perfect result simply because we let it show its work. What is truly wild is how insanely simple this can be. By just tacking on the famous phrase, "Let's think step by step," to the end of our prompt, we trigger zero-shot chain of thought. Researchers discovered this is an emergent ability that literally forces the AI to process logic sequentially. It's an absolute game changer when you just don't have the room to provide fully worked out examples. Now, we scale up to part 3, trees and graphs of thought. We are moving from a single line of thought to complex problem solving, letting the AI explore multiple realities at the exact same time. Because here's the thing. Sometimes a single linear chain of thought just isn't going to cut it for highly strategic problems. Enter tree of thoughts, or TOT. Instead of one straight path, the AI self-evaluates different intermediate thoughts, creating branching nodes. It can look ahead, it can backtrack, and it eliminates impossible solutions. It strategically branches out exactly like a chess grandmaster, mapping out their next moves. But we can actually push it even further. Moving from simple chains to branching trees, we eventually hit graphs of thought, or GOT. Notice how the structure actually mimics the non-sequential human brain. A graph lets thought paths fork, merge back together, and even form recursive loops. If the AI realizes a previous thought from a completely different path is suddenly useful, it just links back to it. It is a massively more dynamic way of reasoning. And the results totally speak for themselves. 5.08%. That is the exact accuracy boost on complex reasoning tasks achieved by graph of thought over standard chain of thought on a standard math benchmark. Now, 5% might sound tiny, but when you are pushing the absolute extreme limits of AI capability, that proves the massive return on investment of nonlinear AI cognition. As powerful as these reasoning graphs are, pure reasoning in a closed text box just isn't enough. So, part 4, connecting to the real world. This is where we give the AI actual agency. Enter the REACT framework. Reasoning and acting. It's a continuous agentic loop. First, the AI has a thought about what it needs to do. Next, it takes an action, like searching Wikipedia or firing up a calculator. Finally, it makes an observation based on what that tool returned and feeds that directly into its next thought. This completely changes the game from static text generation to dynamic, real-world problem solving. And a major application of this is RAG, or Retrieval Augmented Generation. If you hate AI hallucinations, this is the cure. Instead of relying purely on its frozen, pre-trained memory, RAG lets the model grab relevant, factual documents from a database and use them as context. It dynamically adapts the AI's knowledge to the real world, ensuring its answers are grounded in cold, hard facts without any expensive retraining. To put this into perspective, Anthropic ran a fascinating needle in a haystack test. They hid one single fact inside a massive document. With a standard prompt, the AI only found it 27% of the time. But by simply guiding the AI with a prompt saying, "Here is the most relevant sentence," that recall absolutely skyrocketed to 98%. It proves that how we ask the question completely dictates how well the AI navigates its retrieved data. Climbing higher, we arrive at part 5, humanizing AI prompts. We've hit a totally fascinating twist where AI responds to psychological cues just like we humans do. First up is System 2 attention. Standard AI attention mechanisms often get completely distracted by irrelevant noise in a prompt. S2A is modeled after deliberate human focus. We literally ask the AI intern to rewrite the messy context it was given, filtering out all the noise and distractors so it can zero in on the core facts before generating an answer. It's exactly like asking a coworker to summarize a giant, messy email thread before making a decision. Building right on top of psychological theories, we have emotion prompting. By just adding a sentence like, "It's crucial for my upcoming exam to understand this topic," we apply emotional pressure. And believe it or not, this surprisingly motivates the AI to generate much more thoughtful, comprehensive, and engaging explanations. Now, I know what you might be thinking. Emotional pressure on code and weights? Yeah, right. But look at the hard data. Researchers saw a massive 115% relative performance improvement on complex big bench tasks just by using emotion prompts. Injecting human urgency directly unlocks deeper, more accurate AI reasoning. It sounds bizarre, but the data is completely undeniable. We finally reached the apex of our ladder with part 6, evolving AI reasoning. This is the frontier where the AI stops relying on us humans to write its instructions and starts self-evolving. This introduces OPRO, or optimization by prompting. In this setup, we actually step back. We just describe the goal in plain English, and the AI acts as its own optimizer. It looks at its past successes, assesses its failures, and iteratively refines its own problem-solving instructions. It is quite literally learning how to talk to itself better. And this self-optimization leads to the ultimate system, prompt breeder. By applying digital evolutionary algorithms, this system mutates an entire population of prompts. It evolves the task prompts, and get this, it even evolves the mutation prompts themselves. This lets the AI organically discover brilliant, wildly complex cognitive strategies that a human engineer would simply never think to write. The impact here is absolutely staggering. Research shows that these AI-optimized, self-evolved prompts can outperform the absolute best human-designed prompts by up to 50% on complex benchmarks. The machine has officially surpassed our ability to engineer the perfect prompt. And that leaves us with a pretty profound realization. We've watched the AI climb from needing basic, step-by-step instructions to mapping out complex graphs of thought, all the way to autonomous evolution. As the machine learns to perfectly talk to itself, we really have to ask, if AI can now self-evolve its own prompts, how long until prompt engineering engineers itself out of existence? It's a thrilling, maybe slightly intimidating thought to leave you with. Thanks for joining me on this explainer.